Merry Christmas, everyone. I'm Dan. I'm the editor of The Week Junior Science and Nature, the monthly magazine for smart and curious kids. We're back in the new year with a brand new season of Mysteries of Science, which starts on the 13th of January. But in the meantime, I wanted to share with you a very special thing we did earlier in the year. At Cheltenham Literature Festival in October, we got up on stage in front of loads of readers and listeners and put on our very own show called How, What, Why? Expert Answers to Crazy Questions. Here's the live recording that we made. I hope you enjoy it.
Hello, and welcome to the Times and the Sunday Times Cheltenham Festival. Thank you very much for coming here today. I'm Dan Green, and I'm the editor of this magazine here called The Week Junior Science and Nature. It's a monthly magazine that's made for smart cookies just like you. Now then, boys, girls, grown-ups, grannies, granddads, gorillas, I'm so excited because today we have 3 incredible science writers here for you, and also 3 of the most curious adults that I know. You can take that as you will. Isabel Thomas is a multi-award winning author, and she writes regularly for the Science and Nature magazine. And in her book, The Bedtime Book of Impossible Questions, she's going to show us how asking and answering the craziest sounding impossible questions can actually reveal more than you know. Well, every month, children write in to us at the Science and Nature with questions that just literally make our heads spin. And we call them head scratchers because, well, actually, you know why. You can guess why they call them that. So we're talking about questions like, why is a candle flame pointy? And if you took all of the fish and living things and ships out to the sea, would the sea level fall? And by how much? And possibly my favourite style of question is, who would win in a fight? So who would win in a fight between an African elephant and a diplodocus? Well, actually, let's put that to the test. Who thinks would win a fight? Let's do a little mini experiment, right? Have a little think. Who would win in a fight between an African elephant and a diplodocus? If you think African elephant, what I want you to do after 3, not right now, is to make a sound like an African elephant, right? Like an elephant, a big trumpeting, like moo, something like that. Is that what elephants make? Is that the sound that elephants make?
Yes.
Or you can moo like a cow or hoot. And if you're on Team Diplodocus, let's say, well, Diplodocuses are heavy animals, aren't they? So you can stamp your feet. So after 3, okay, who would win in a fight between an African elephant and a Diplodocus? Hoot or stamp your feet. 1, 2, 3. Wow. I'm not sure. I'm genuinely not sure. There was a lot of foot stamping. But luckily, guys, we have on hand here Peter Gallivan, who writes regularly. He writes every issue, not just regularly, every issue he writes the head scratcher section. So he's really good at answering questions like that. And he is also the family programs manager at the Royal Institution. And you'll also be answering questions on, or talking about asking questions and your book, How to Build a Skyscraper. And Maggie Aderin-Pocock needs no introduction. She's a space scientist, presenter of BBC's amazing Sky at Night magazine. And recently, Maggie, you guest edited a special space edition for Science and Nature, which was fantastic. We were so thrilled.
It was really good fun. Thank you.
Thank you very much for doing it. So that's the how of how, what, why. What about the what? Well, I'm going to give each of these amazing guests a chance to speak to you a little bit more about their books, and then I'm going to set you guys loose on them, okay? So you can think of the craziest, most impossible, most head-scratchy questions that you can. Some of you may have come here pre-armed with a question. At the end, there'll be a time for asking these guys your questions, and there'll be a mic going around. And then What about the why, finally? Well, why don't we get started? So, without further ado, give a big Cheltenham cheer for Isabel Thomas.
Thank you so much. Thanks so much, Dan. I'm going to start by asking all of you a question. What do you think it takes to become a scientist or a science writer like us? What kind of person do you think you need to be? Has anyone got any ideas? Put your hand up and I'll ask if I can... Bright lights. Okay, in the red and pink top.
You need to be really curious.
Think really curious. That is a brilliant answer. What's your idea? Smart is one idea. Let's go all the way over here. What's your idea? Ambitious, I like it. And what's your idea? Being very smart as well. And let's take one more from all the way over here. What do you reckon?
Try hard.
Trying really hard. These are all great ideas, and lots of people say this to me when I go and visit schools and talk to readers. And actually, I say all that you need, and there's a massive cue in the title of our event, is questions. That's what gets everything started, whether you're a scientist or a science writer. And they can be sensible questions, like, what makes the sky blue? But even better, I think, they can be silly questions. And scientists are brilliant at asking and answering silly questions. They even have a prize every year for the silliest, the most funny questions asked by scientists. Now, who's heard of the Nobel Prizes? It's not those, okay? But they are named after them. If you look up the Ig Nobel Prizes, you will find amazing questions that really have been asked and answered by scientists. Questions like, are cats liquid or solid? Now, this was asked by a scientist who, scientists and mathematicians, they don't spend all their time doing science and maths. They spend quite a lot of time scrolling on the internet, like all of us. And this scientist saw lots of pictures that looked a bit like this. Does anyone have a cat who likes to hide in very strange places? Tell me where your pet cat likes to hide.
In the fridge.
In the fridge, so we might have. That is very strange. Does it open the fridge itself, or do you just let it in?
It can just slip in.
They can. So it changes its shape to get into the fridge. So we have a fridge-shaped cat. What about your cat?
In my dad's cupboard.
In your dad's cupboard, you have a dad's cupboard-shaped cat. Brilliant. What about your cat? The washing machine cat. Have you told that cat it's a very dangerous thing to do? So we have a washing machine and very clean-shaped cat. Yep. Fruit bowl-shaped cat, a lot like my cat here. Yep.
In the TV.
TV-shaped cat. Brilliant. That is an ambitious cat. Yes.
What? In my dad's clothes drawers, completely shut out.
A drawer-shaped cat. That's amazing. And let's have one more. What's about your cat? Another drawer-shaped cat. So all these cats taking different shapes. And that's exactly what this scientist noticed. A cat will take the shape of whichever container it decides to hide in that day. And of course, that's one of the main properties of a liquid. If I poured water into this bowl, it would also become bowl-shaped. So this scientist decided to do the maths. He studied fluid dynamics, which is the science of how gases and liquids behave. And on doing the sums, he found out that cats are indeed technically, mathematically liquid. So that completely changes the way that we think about cats, and we can understand their sort of 9 lives. Now, I'll put my cat down here. There are some people who are even better than scientists at asking silly questions. Who do you think that could be? Let's have a guess. What do you think? Us, yeah, this audience in Cheltenham, and specifically the children in this audience. And I love going and hearing children's questions and trying to answer them. And one of the best I ever heard, one of the funniest, started, can dogs? Does anyone want to guess what the end of that question might be? Can dogs? Who has a dog? Who wants to have a guess? Yeah. So finish the question. Can dogs talk? That is a brilliant question. And actually one I've answered in the Impossible Questions book. What's your idea?
Can dogs fit in a fruit bowl?
Can dogs fit in a fruit bowl? I couldn't find one that could. But don't try this with your poor dog if you have one at home. Let's have one more idea right from the back in the yellow jumper. Shout a little bit louder. Can dogs understand us? Probably not today because I'm talking absolute nonsense. So these are brilliant, silly questions, and it shows just how good you all are at coming up with them. But the question that I really loved was, can dogs swim in ice cream? And I thought this was such a brilliant question. And it was asked by a little boy called Theo. He was in year 2. And I thought, I need to find out. And I want to give him a seriously scientific answer. And I found out that scientists who really do study absolutely anything you can think of had once filled a swimming pool with guar gum. Now, guar gum is a food additive people actually use to make ice cream all gloopy and thick. So they turned this swimming pool, about the size of this room, into a gloopy ice cream mix and challenged human swimmers to swim through it. Now, hands up if you think they swam faster than in water. Hands up if you think it was slower going through the gloop. Brilliant. Well, you're all wrong. Weirdly, they found, although it's a lot harder to move your arms and legs through the gloop, every time you do push, the gloop pushes back much harder than water. So overall, they swam exactly the same speed. So I could say to Theo, dogs absolutely could swim in ice cream, but don't try this at home if you have a dog. Who has a dog? Okay, it would be a waste of perfectly good ice cream, and it would be a waste of a perfectly good dog, okay? So no going back and experimenting. Some silly questions, some impossible questions, we have to answer through thought experiments, and that can be brilliant fun. But some questions we can answer through real experiments. Now, I go to schools a lot, and I often talk about books that I write about scientific things like climate change. And children, of course, ask, what can we do? What can we do to help? And I might talk about things like eating a bit less meat, or how insects are the food of the future because they're so much less intensive for our planet to farm insects. So the next question is, what do insects taste like? And this one we can answer with an experiment. So who would like to volunteer to taste some edible insects and try that and help us answer that question about the future? Lots and lots of volunteers now. So in the red and black check top, and let's choose, do you want to come in the camouflage top? Come up on the stage really carefully. Now, I should just check with your parents so you're not allergic to crustaceans or mollusks, because we have very similar proteins in our insects. So if you stand here for me, let's choose a couple more volunteers from this side. Do you want to come up? And from this side, would you like to come up?
You'll be fine.
Go for it. And does anyone feel like they really want to know the answer, but they don't want to try themselves, but they think their parents should do it for them?
This mum here.
We've got a volunteer here. Do you want to come on stage? So let's have a look at the insect treats I have got for you to try. So I should point out straight away, so no crustacean or mollusk allergy. No, you missed your chance there to get off stage.
Yes, I have.
So you can come and stand here. So I've got 2 types of insects that you can choose from, and I'm going to sprinkle some of them. They are food. I don't suggest that you just go outside here into Montpellier Gardens and start plucking insects off bushes to eat, okay? They are produced as food, so we know they're nice and safe and hygienic. And if I scatter some under the visualizer, then everyone will be able to have a look of your choice. So we have mealworms, and these are beetle larvae, so baby beetles. Now, they are roasted, I should point out. Should you think that, and we have some lovely, crunchy locusts. So we can see our locusts there, and even their lovely heads. So, if I put them into these glasses, I can give you a choice. Someone's already saying mealworms because I think they're a bit smaller, aren't they? So, locust or mealworm, and don't eat it straight away. I'm going to get everyone to count down before we eat them, okay? So we can all taste them at the same time. Mealworm. So, can I sprinkle one onto your hand? There you go. Locust or mealworm? Locust. Brilliant. Try and get a nice crunchy one. Locust or mealworm, or both?
Both.
Mealworm. Have a little baby beetle there. Okay, and locust or mealworm? Locust. Does that look delicious? Can you see its little eyes? Fantastic.
Locust, babe.
Locust, fantastic. There you go. I'll give you an adult-sized portion. Okay, so let's all count down from 5. Okay, ready? 5, 4, 3, 2, 1. Go for it. Have a careful look. Oh, we're looking very happy. Who wants to tell me what they think they taste like? What they remind you of?
Taste delicious.
Taste delicious. Brilliant.
Yummy.
Yummy. Fantastic.
Very crunchy.
Very crunchy. And what do they remind you of?
Cocoa Pops.
Cocoa Pops, this sounds good. And how about you? Fantastic. So Twiglets. So I have lots of leftovers. So if anyone wants to come to the book signing tent afterwards, you can also have a lovely, delicious insect to eat. So a massive round of applause for our volunteers. Thank you so much, Aidan. Well done. Well done. You go sit down.
Thank you, guys.
So we've seen into the future now, and we've seen that these impossible questions can lead to the best answers and the best science. So now I'll hand over to Peter to take you to the next stage.
Lovely. Fantastic. I'm just going to have to clear up these.
You should eat
I'll give
them.
you your cats. You can have a drink if you want. There we go. Lovely. So thank you all for coming. So as Dan said, I work for the Royal Institution. So we're a charity, and I do stuff like this, cool science events all year round. But usually I'm in Dan's seat, so it's very exciting to be talking to you all today as well. So just like Isabel said, so I'm a scientist, I work in science, and the reason I love working in science is because I get to just answer questions all the time. And that's something I've done all my life, ever since I was really, really young. So what I thought I'd do is I'd bring you a couple of interesting things I found in my house, and I'll ask you some questions about them, and we'll see if we can find some stuff about them. Brilliant. So from a very young age, I used to hang out in my grandma's house a lot, and Grandma's house is always full of really cool stuff. So I would like wander around and play with whatever stuff I could find. And then she had 2 little china birds that I smashed together because I was trying to make them talk. And then I wasn't allowed to play around with her stuff anymore. But one thing I was allowed to play with was this little thing here. So it's kind of a brass-looking duck. I'll put it under the visualizer so you can see what it looks like. And I want you to guess, what might this thing be? So it can... Clack like that. Any ideas? What might this thing be? Oh, yeah, right at the back. A hair clip. It's not a hair clip. Yeah.
Peg.
A peg. Not quite. Yeah, here. Some sort of chopsticks. That would be good, wouldn't it? You could like pretend you're a bird, and there we go. You could eat your things like that. No, one more guess up on the front. A nutcracker. No. What it actually was is you can hang it up on your wall and you can clip your bills in its bill. There we go. There's a joke for the parents. But I loved, when I was a child, just wandering around, looking at things and wondering, why is that shaped like that? Why might its beak open? Why might it have a little hole here? And that's just what scientists do. We kind of look at things, ask questions, and those questions help us understand how things work and why they're designed like they are. And at the same time, I used to... does anyone's school have a nature table? No. Oh, yes. So at my school, in my classroom, we had a nature table, and you were supposed to bring in cool stuff that you'd found. And I thought that I always brought the coolest stuff. But one week, I was walking to school, and I thought it was a frog, and I came up close, and it was actually a frog that had been run over by a car and had been squished flat and dried out. And straight away I was like, Mrs. Stamp is going to love this. So I picked it up off the floor, came in, I was so excited. I was like, Mrs. Stamp, look at this frog I found. And she was disgusted. She didn't let me put it on the nature table. So I went home, I was very sad. And then the next week, This happens at all school. Nits were going around our school that time, and just for Christmas, I'd got this little magnifying pot where you could, if you were collecting insects, say some beetles or a ladybird, you could put them in your little insect pot. And so I thought, well, I wonder what a nit looks like under this little pot. So as my mum was getting my nits out of my hair, I put them in a little pot. Mrs. Stamp's going to love these. So I came into school the next morning, and for some reason, Mrs. Stamp didn't like me bringing live nits. But it was amazing. You can look at them, and you could see them crawling around. You could see some of the eggs on your hair. And again, I was interested. I was asking questions. Mrs. Stamp didn't particularly like me asking those questions, but I really enjoyed them. And that's why I then went to university to study zoology. So I spent 4 years learning all about animals. And that's why most of the questions I like Dan said, thinking about whether an elephant or a diplodocus could win in a fight. Kind of, that's what I learned at university, which is pretty cool. There wasn't a whole month of like, this animal versus that animal, but it was still quite good fun. So after school, after university, I went traveling a bit, and I went to a volcano. I went to a live volcano, and I was walking along, and I saw volcanoes. What color do you think a volcano usually is? Anybody? Yeah, right at the back with the sparkly top? Black, yeah. So most of this volcano is black, but then I found this interesting looking rock, which is like, it was multicolored. This was, it caught my eye. And then if we look at it under the visualizer, do you see it's got all these little tiny holes in it? And actually, even though this is a rock, this rock floats in water, which is really weird. I've never seen a rock that floats in water. And it's got all these little holes. So who might think, why might it have all these holes in it? Yeah, at the front? Yeah, it's a bit like a sponge. So basically, when a volcano erupts, it shoots out bits of rock, and as they cool really quickly, all the gas inside them expands, and it makes them a bit like an aero, like a big puffy. So because it's full of pockets of air, it can float. And then it's got all these lovely colors on it. So the orangey bit is some kind of rust from iron, and then all the other colors are all different metals that were inside that volcano. Luckily, this didn't erupt when I was there. There was a bit of smoking a volcano, but that was all I've seen. And now I've got one final thing I'd like to show you, and this one, I'd like to see if anyone can guess what this thing is. So I'll put it under the visualizer. So can anybody, where haven't I been? Let's go right to the back with the green shirt, yeah? It is some coral, very, very good. So this was some coral I found on a beach, and coral, I think, is a really cool thing. Well, who knows what it is? What is coral? Yeah, on the front. So it's not a plant. What is it? Yeah, with the R?
It's a type of animal that has.
Yeah, so it's actually an animal. It's lots of little tiny, they're a bit related to a jellyfish, and you have all these little tiny things living inside this. And what I love about coral, which I think is a lesson we can all learn, it's a little tiny thing, but actually over time, coral piles up and builds islands. So lots of islands in the Pacific Ocean are built by coral. So if you're having a day when you feel like you've not achieved much, just think this little coral in a couple of thousand years will make a whole island. Lovely. So that was kind of all the things I had to show you. But basically, if you're interested in science, as Isabel said, you just ask questions. Look around. Find some squashed animals in your garden, see what's growing in your hair, see what you can find on the beach, and just ask questions. And that's basically all what a scientist is. Thank you very much.
Thank you, Peter.
Is it possible to have the slides? Thank you. So I want to talk to you a little bit about the book, but a little bit about me. And I want to ask try and give some answers to two big questions. Because my book is all about sort of asking questions, and so the limit of our knowledge as it stands at the moment. And so the book is called Am I Made of Stardust? And that'll be the first question I answer. But first of all, now I'm having a clicker problem. Aha! First of all, I wanted to tell you why I became a space scientist. Because I became a space scientist almost from the get-go. Almost from the moment I was born, I wanted to be a space scientist. And that's because I was very excited about people who had been out into space. People like, hopefully, Yuri Gagarin. I love the way he turns up on cue. Yuri Gagarin was the first person to travel out there into space. And he must have been terrified when he did it, because in those days, spacecraft have a habit of blowing up on the launch pad. But he went into space and went round the Earth and then landed again. And when he landed, the world went wild. We had our first person in space, our first cosmonaut, our first astronaut. And then, but when I was born, growing up, I was born in 1968. And in 1969, this happened. Does anyone know what this is? I saw that hand go straight up. What is it? Neil Armstrong, one small step for man, one giant leap for mankind. Those are the words he uttered as he stepped out onto the moon's surface. And so I was born in 1968, so I don't remember the moon landings. Oh, yes, I'm getting ahead of myself now. I don't remember the moon landings, but they had a big impact on me. In fact, people were saying that I was taking my first wobbly steps as Neil Armstrong was taking his giant leap. Now, it started off with the moon landings, but before I knew it, I was watching other science fiction like the Clangers. Now, does anyone here know who the Clangers are? I knew you were a good audience. I love the Clangers. I have always loved the Clangers. And so the Clangers, one of my favourite things about the Clangers is when they're sad, they used to go, ooh. And as a little girl, that just touched my heart so much. And so, yes, the Clangers. But it turns out the Clangers are a bit of a gateway. You start watching the Clangers, and before you know it, you're watching other hardcore science fiction. So could you do the next slide? Thank you. You're watching other hardcore science fiction. And again, please. Star Trek. Now, for some of the younger members of the audience, you might not be familiar with Star Trek, but Star Trek was about a gang of people who travelled through space, and they came from all over the world, and there were some aliens in there as well. Do you see the guy with the pointy ears? And also, this was my role model. This was Lieutenant Uhura. She was the communications officer. Captain, I have the Klingons online. And so I was like, yes, when I grow up, I want to go out into space. This was my crazy idea. But I'm sorry, can you do the next slide? Thank you. But for me, and so when I was about 7 years old, this was my crazy dream. I wanted to travel out there into space and see the curvature of the Earth, just as Yuri Gagarin had done. Then I wanted to travel to the moon and walk next to the footsteps of Neil Armstrong. Not on top of them, because that'd be really rude, but, next to the footsteps of Neil Armstrong. And then I wanted to go out and meet the Clangers. I'd loved them all my life. I wanted to meet them. And then I wanted to go out beyond, just like they do in Star Trek, and go to what we now call exoplanets. So exoplanets are planets going around the stars we see in the night sky. When we look up at the night sky, we can see, on a really good, clear night, about 3,000 stars. But in the whole of our galaxy, the Milky Way, there are approximately 300 billion stars. And what we're doing now is we're detecting some of the planets going around those stars. Now, I mentioned there's 300 billion stars in our galaxy, but what I want to do is a quick thought experiment. Just as Isabel was saying, thought experiment. So how big is a billion? Because if someone ran over and said, Maggie, here's a cheque for £1 billion, would I be happy or sad? really damn happy. But how big is a billion? And so to work out how big a billion is, I want us to do a thought experiment. I want us to sit here and count from 1 to 1 billion, doing one number a second. So 1, 2, 3. This could get very boring. But my question to you is, how long will it take to get to a billion if we're doing one number a second? So how long is 1 billion seconds? Now, I'm going to make it this sort of a bit of a bidding war. So put up your hands if you think it's more than an hour. Okay, I think that's most people. But, okay, keep your hands up if you think it's more than a day. A week? A month? A year? 2 years? 10 years? 20 years? 30 years? Still some hands up? 40 years? Okay, anyone who's still got their hand up, it's too long. 1 billion seconds is actually 32 years. And just as Isabel and Peter was saying, I go out and see a lot of school kids. Over the llast 15 years, I think I've seen about 200,000 school kids. And I must admit, I'm knackered. But the thing is, it's sort of, what I like to tell the kids is, if you sit there for 1 billion seconds, you'll be older than your teachers by the time you get there, which is pretty terrifying. So 1 billion seconds is 32 years. So what I'm saying is, in our local galaxy, there are 300 billion stars. And now we're detecting the planets going around them. So this was my crazy dream as a child. But for me, it all sort of went a bit horribly wrong when I went to school. because I went to 13 different schools when I was growing up. And when I tell kids this, they say, how naughty were you? It wasn't like that. My parents split up when I was quite young, when I was 4 years old, and sometimes I was with my mum, sometimes I was with my dad, so I moved around a lot. But also, I have a condition called dyslexia. Oh, sorry, I'm getting ahead of myself. I have a condition called dyslexia, and it meant that, of course, when you start off at school, it's all about reading and writing, and I found that really hard. And that's why when Isabel said she's written 200 books, it's like, whoa, that's amazing. Because for each book, I find it really hard, because I have crazy thoughts going in my head. As dyslexic, it's full of lots of creativity and ideas. But what I find is when I try and type it down, I'll type it in and then I'll try and read it back. And I read what I think I've written. So I read what's in my head and not what's on the screen, which is right pain. But what I find is now if I listen to what I've read, so I use an audio reader, I can pick up mistakes that the editors can miss. So it's usually with any challenge, you can find a solution. And that's my solution for getting over my dyslexia. But dyslexia also means I'm very logical, I like storytelling, and so it's nice to use these talents now that I'm older. But when I was at school, I was sort of at the back of the class, with the safety scissors and the glue, a bit sort of disconnected. So now I see dyslexia as my superpower, but when I first started, I found it quite hard. But I would say crazy dreams can come true, because this is one of my favourite pictures. Because I don't know if you can see, that's me, rather large, and that's a clanger. And so standing next to the clanger, holding hands with the clanger, is a little model of me. Because I said that I became a space scientist because of the clangers, they actually made an episode of the clangers called The Visitor, and they made a little Maggie model. And my crazy dream of getting to meet the clangers came true. And I went to Altrincham where they make the clangers, and I sort of saw my model, and I was sitting there, and there were tears coming down my eyes, and I held the soup dragon in my hands. And my daughter was saying, "Mum, it's a puppet." So crazy dreams can come true. And one of my other crazy dreams was, oh no, I'm getting well ahead of myself now. It was I got to meet Lieutenant Uhura. So the person who played, Lieutenant Uhura, Nichelle Nichols, I got to meet her too. So yeah, but also be careful what your kids are watching, because it can lead to all sorts of trouble. But yes, crazy dreams do come true. So I wanted to try and answer 2 questions in a very short time that are written in the book. And the question of the title of the book is, am I made of stardust? Now, the simple answer is yes. But I wanted to go in a bit more detail than that. But to understand if we're made of stardust, what are we made of? What are the elements in our body? So if we look at the next slide, which is going to come, yes, the next slide, these are the elements that make up our body. So 65% oxygen, sort of about 18% carbon, only about just under 10% hydrogen, and then we've got sort of a mix of other things. So these are the elements that make up the human body. It makes up most of life on Earth, in actual fact. So where do these elements come from? Well, if we look at the hydrogen is the stuff that was in sort of the early universe. And so that was sort of around, so much of this hydrogen in our body was sort of almost around soon after the Big Bang. But it's all these other elements, where do they get made? So could you click this video, because I don't know if it's going to work. Well, these elements are actually made inside the heart of a star. So here we are travelling in to the heart of a star, and as we do this, the temperature is rising, the pressure is building up. This is an incredibly dense place. And these are atoms. And what happens is that's 2 hydrogens have come together, and what they've done is they've released some energy, and they've also made a new element. So this is where the elements in our body are made. We truly are stardust, because the elements in our body come from the heart of stars. Okay, and this whole process is governed by the equation, Einstein's famous equation, E equals mc squared. And now E is energy, M is mass, and C, hopefully if it appears, is the speed of light. Now, the speed of light is incredibly large. 300 million metres per second. That's how fast light travels. So it's I travelled in from Guildford earlier today, and I would have loved to travel at the speed of light. But I was somewhat slower on the sort of M25 and coming through. So yes, so this equation tells us that when this fusion process happens, small amounts of mass are lost, and they get converted into huge amounts of energy. And this equation governs one of the things we're trying to do here on Earth. We know that the stars shine, we see the light, we feel the heat, we actually get some of the UV energy coming from the stars because of this equation. And one of the things we're trying to do is use this equation to generate energy here on Earth. Because we're talking about fossil fuels being bad, and although we're talking about wind and other energies, a fusion would be a great way to produce energy here on Earth. So, how does that stuff get into us? Well, it happens in a process called a supernova. If you get a star, just like our star, but bigger, maybe 10 times bigger, when the pressure of the star starts to sort of overcome, what happens is the fusion process keeps the star pushing outwards, and the gravitational force keeps the star pushing inwards. And when this happens, what you get is when you start running out of fuel, the gravitational force gets bigger and bigger and bigger. It squishes the star into something so small that it goes supernova. Now, supernova are some of the brightest things we see in the universe. We can see supernovas happening in other galaxies. And when supernovas occur, they produce more energy than the sun has throughout its whole lifetime. And so in a matter of minutes, all this energy is released. And that's the energy is released, but also the elements are released. And then what happens is that exploded star will form a nebula, and then new stars will form, and they'll take on the carbon, the helium, all those elements that were formed in the heart of a star, and they'll start a new star, they'll start new planets, and they'll start, hopefully, new life forms like us. So that's where the elements in our body comes from, the heart of a star. We truly are stardust, and we really are special. So the next question I want to ask is there life out there? Now, this is one of the questions that I've always wanted to know. I've watched Star Trek, they met aliens. Are the aliens really out there? And it's quite interesting if we sort of look at our planet, because our planet Earth, is the only place we've found life in the universe. And if you look at our planet, life in our planet is so diverse, just so wild, and we've got airborne stuff, things living in water. We've just got such a variety of life. And we're looking for that similar life out there. And we keep on looking and we keep on looking, but we haven't found anything yet. And it's quite interesting, because where do we look? Well, we look in places where we think are quite similar to Earth. So one of the things that seems to be very important to life on Earth is water. Water, about 70% of our bodies are water, and about 70% of the Earth's surface is covered in water. So we're very much a product of the planet we live on. But we're looking for life elsewhere in the solar system. Oh, actually, could you hit this video? Ah, there it goes. And so we're looking, and so there's something called the Goldilocks zone, which I think is a great way to describe things, because it's a zone which is sitting away from a star, where you're not too far away from the star, and you're not too close to the star, but you're just right to have liquid water. And so we're looking at planets in this Goldilocks zone, and we know that Mars used to have liquid water flowing over its surface. So Mars seems like a great place to look. And what this is it's a rover called Fetch, which is a perfect name for this rover because it's doing just that. It's other rovers are travelling around Mars and they're collecting samples. And what Fetch does is it goes and collects those samples, scoops them up, and it's sending those samples back here to Earth. Because for over sort of 40 years, we've been looking for life on Mars. Was there ever life on Mars? Are there Martians? And we haven't found any. But when we do these experiments, we have to do them on the Martian surface. And so the experiments we do are quite simple. But with Fetch, we can actually bring some of those samples back home to Earth. We need to be very careful that we don't contaminate Mars, or we don't let Mars contaminate us. But then we can do the experiments in big labs and discover if there's life out there. So that's Fetch. But how about other places in the solar system? Well, one of the things that we discovered is we've started looking for life in places we didn't look before. And we started looking for life because we found life where we didn't expect it. This is sort of an image of a deep ocean. And I don't know if you've heard of the Mariana Trench, the deepest place in the ocean on Earth. And if you look, it's about 11 kilometres deep away down below sea level. So I'm having difficulty with the slides. Yes, so 11 kilometres deep down below sea level. Now, down here, you're far away from the sunlight. We thought life couldn't possibly exist down here. But when we did analysis and sent probes down there, we found out that there's life. Life living off thermal vents bubbling from the heat of the Earth. And so if life can exist there, where can life exist in our solar system? So rather than just looking in on planets, we started looking at some of the moons of Jupiter and Saturn. Sorry, could you click on this? Thank you. Now, this is one of the moons of Saturn. It's called Titan. It's one of the moons, and this is actually a probe falling through the atmosphere of this moon of Saturn. So this moon is quite small, but it has an atmosphere thick with methane. But it does actually have an atmosphere. And so the sound you hear is the sound of the probe as it falls down through the atmosphere. And then this is what we can see below. We can see mountains, but not of rock, mountains of methane. Because this moon is going around Saturn, and Saturn's a long way from the sun, it's cold. Now, methane, as humans, we do actually produce methane, and it comes out, well, okay, so it comes out as a gas from our posteriors, let's put it that way. But here, methane, because this moon is so cold, methane is a liquid, and it flows over the surface. And so this is one of the places where in the future we might see maybe the seeds of life developing and growing. And so, yes, it's amazing to see this. And this is the furthest we've been in the solar system, the furthest we've sent a probe, one of the moons of Saturn. So one of the things that we've been trying to do is work out if there's life out there. And to do that, we've been using something called the Drake equation. Now, the Drake equation is a guesstimate. It sort of puts in various factors and said, how often do stars form in our galaxy? And if a star forms, how often do they have planets going around them? And so it's got all these different factors. And it's quite interesting to sort of explore some of them. Because one of my favourite factors is how long does a civilization last? Because I love this idea that one day the aliens came down to planet Earth, their spaceship arrived, and the door opened. The aliens stepped out and looked across. And what did they see? Dinosaurs. So they went back in and went somewhere else. because if our civilizations don't overlap, then how are we going to meet the aliens? But another important factor is, how often does life occur on a planet? And if you look at this in more detail, look at life here on planet Earth, it's quite fascinating to see that, first of all, you have the sun forming, and then the planets form around the sun. And you can see how quickly the Earth developed. And you can see that up there, where it says the moon, that's when a planet the size of Mars collided with the Earth and formed the moon. So that happened about 4.5 billion years ago. And so when that happened, the Earth was the Earth was very hot, very humid. When this collision happened, it spewed out sort of debris all over the place. But only a few million years after that, life occurred on Earth. And if you see it as a timeline where the Earth formation happens at midnight, and then the moon collision happens at a few minutes to 1, but life starts occurring on Earth at 3 o'clock in the morning. So almost as soon as life could occur on Earth, it did start occurring on Earth. So this gives us an understanding that maybe life finds a way. And it means, is life more probable out there then? Or is it just here on the conditions of Earth? So we've been looking for life through our solar system, but now, as I say, we're looking for life beyond, in these exoplanets, planets going around other stars. And we're finding thousands of them. And the more we look, the more we find. I worked on something called the James Webb Space Telescope. And the James Webb Space Telescope is designed to actually look for some of these exoplanets out there. And we detect exoplanets in different ways. One way is a star will wobble as a planet goes round it, and we can detect the wobble. Another, and one of the most favourite ways, is to actually look at, as a planet goes in front of a star, the light from the star will dim by a small amount. And so we can actually detect the planet that way. But what we're now able to do is actually, I'm getting ahead of myself. What we're now able to do is actually look at the atmosphere of that planet and see what gases lie in that planet. And we're finding Earth-like planets with water vapour in their atmosphere. So these are the sort of questions that I love to ask. And these are the sort of questions that I think we need to ask as scientists. My final quick question is, will I ever make it to the stars? And because as watching Star Trek, I've always wanted to get out there. And the answer is maybe. Because there's so many challenges to face. Travelling from our solar system to the next door neighbour solar system, travelling at 16 kilometres a second, takes 76,000 years to make that journey of 40 trillion kilometres. So it just seems like a long way away. But the late, great Stephen Hawking was championing a new project called Breakthrough Starshot. And with Breakthrough Starshot, what he was doing was coming up with a new way of travelling through space. It's called a solar sail. And what you can do is you set this solar sail up in space, and it's just a big sheet of metallized plastic that sits in space. And in the centre is a tiny space probe. What you do is you have a bank of lasers on Earth, you shoot the lasers up, and it accelerates the solar sail to 1/5 of the speed of light, or warp factor 1/4. So with this technology, we hope in the next 20 or 30 years to actually be travelling out to seeing these exoplanets and potentially finding life out there. So I think each and every one of us should keep on asking questions, because there's so many things we don't know, and we need young people like you, and the grown-ups too, to help us find the answers, to help us understand our place in the universe. So I'll stop there, but thank you very much.
Thank you, Maggie. Thank you, Maggie. Thank you so much. Thank you, Isabel. Thank you, Peter. I mean, I thought that was absolutely fascinating. I've learnt loads, and I hope you have. I've learnt what a thought experiment is. I was starting to count to 1 billion, and I'm glad we didn't carry on with that, because we'd be here for a very, very long time, yes. And I think we can all agree on 2 things. The more we ask questions, the more we find out. And the second thing we can agree on is poor Mrs. Stamp. So I think we've got enough time for a few questions from the audience. Has anyone got any questions they'd like to ask? Stick your hands up, and we've got a microphone that's going to go round. Speak nice and clearly.
How big is Earth?
How big is Earth? Maggie, would you like to answer that one?
So when we say how big is something, it's nice to compare it with something we know. Now, the thing is, Earth is a planet, and it's sort of one of the, it's not, you know, as planets go, it's not too big, it's not too small. So if we start at the beginning of the solar system, we've got Mercury, and Mercury is sort of about the size of our moon, so it's not that big. Then we get to Venus, and Venus, Earth and Mars are all about similar size. And then if we go out to sort of beyond the Earth and beyond Mars, we get the gas giants, and they're huge. And to put those in perspective, if we take one planet Earth, and you sort of, let's say you take an Earth-like ball, you can fit 1,000 or over 1,000 Earth-like balls into one Jupiter. So Jupiter is almost 1,000 times the volume of Earth. But right at the heart of our solar system, and then actually you get Jupiter, you get Saturn, which is slightly smaller than Jupiter, then you get Uranus and Neptune, and they're sort of ice giants. So yeah, they're quite big, but not as big as Jupiter. But the thing that really dominates our solar system is the sun that sits at the centre. Now, if you take all the mass of everything in our solar system, 99.8% of all the mass in our solar system sits in the sun. So the sun has most of the stuff in it that is in our solar system. But if you take that Earth ball again and start dropping them into the sun, you can fit 1.3 million Earths into the sun, especially if you squish them down, you really squish them in. You can fit 1.3 million Earths into the sun. So the Earth is a sort of an average sort of planet from all the exoplanets we've been seeing, but a star, because our sun isn't a very special star, it's an average star, you can fit 1.3 million Earths into our local star, the sun. So in the scheme of things, the Earth is pretty small. But compared with you and me, it's pretty big.
Thank you. Over here.
If we're made of like 60 to 70% water, does that mean we're a liquid or a solid?
That's a good question. Well, that's sort of...
You're a cat.
Yes, exactly. I was going to say, I think the cats can say something, can't they, Isabel?
It's really interesting, isn't it, that all animals are largely water, and some, like jellyfish are pretty much 96% water. So you think, well, how do they even hold their shape? Cats are quite a special example, I think. They're very, they have a skeleton, they have solid parts, but they're particularly fluid. So if you're predicting how a cat's going to behave in any situation, the maths that describes a liquid is very good. But humans, I'd say, we're a bit more solid, aren't we? So we're probably a little bit more fragile, a little less squishy than a cat. Although we've got all that water in our bodies, we've also got some very fragile parts like our large skulls with our very watery brains inside, which is why we need things like bicycle helmets if we're going to do any stunts, whereas a cat can just do whatever it wants. So don't try and go full cat, but yes, you are largely liquid.
Yes, my body definitely doesn't float.
I don't think we're fitting into that bowl, are we?
How many galaxies are there?
Ooh. This is a very interesting question. And until recently, we didn't really know the answer. And one of the things I find fascinating is how our understanding of the universe has changed. Because if you go back sort of a few 500 years, everybody thought that the Earth was the centre of the universe, and everything rotated around us. So the sun, the moon, everything went around us. And then people came along and said, "That's not right. The sun's the centre of the universe." Yeah. Okay, the sun's the centre of the universe. People said, "No, hold it. That's not right either." And then people started realising that all the stars we see in the sky are suns like our sun. And so I mentioned there's 300 billion stars in our galaxy. Well, the Hubble Space Telescope, have you heard of Hubble? Hubble Space Telescope has been out there for nearly 30 years. It's been doing some amazing stuff. But the Hubble Space Telescope took a picture called the Hubble Deep Field, and it looked at what we thought was a piece of empty space, and sort of just a tiny piece of space which we thought was empty, and it looked at it for 10 whole days. And then when we got the data back and analysed it, we realised that that piece of space wasn't empty at all. It was actually teeming with galaxies. And so if you can work out, 1 millimetre at arm's length, how many galaxies are in the whole of the universe, we reckon now that there's about 200, wait for it, billion galaxies. Now, our galaxy contains 300 billion stars, and then there's sort of many galaxies bigger and smaller than ours. So out there must be billions upon billions upon billions of stars, billions upon billions of planets. So if you ask a space scientist today, do you think there's life out there? Most of us will say yeah, because there's so many stars, so many planets. We think there's got to be life out there, but we're not sure it'll be able to find us out of the vastness of space. So yes, about 200 billion galaxies. That's quite a mind-boggling number.
Yeah, that's definitely mind-spinning, isn't it? I have a question over here.
Why do we have fingernails?
Now, our resident zoologist on the panel, why do we have fingernails?
Yeah.
I mean,
that's a very interesting one, because actually, if you look at, have you ever seen a gorilla or a chimpanzee's hands, especially a gorilla's hands, they look almost identical to us. They have fingerprints, they have fingernails as well. So often with a question like this, what is useful to think is if you go back to other animals that are further and further apart from us and try and find out where fingernails arrive. So like all other primates, so monkeys, chimpanzees, gorillas, they've all got fingernails. So if I go one step back, then we're looking at like cats, dogs, other mammals, they all have got fingernails. If you then go back further to reptiles, most reptiles have claws, which are related to fingernails. And then I would go back to amphibians, so frogs. Does frogs have fingernails? Does anybody know?
No.
I don't think they do. So that would then suggest that fingernails evolved sometime when an early amphibian became a reptile. So
it wanted to pick its nose more easily.
Yeah, and I think probably what it was that the amphibians lived mostly in watery environments. They were kind of in the soft mud, whereas then when reptiles came properly up onto the land, they'd need claws to kind of claw around. So that's probably why we have fingernails, because a reptile 300 million years ago needed to walk on land.
Well, I'm convinced, definitely. I think we've got time for one more question. Is that about right? Yeah, OK, so we'll have the last question.
What is the least toxic animal?
The least toxic? Right, now there's a question. Ooh. Well, perhaps we ought to start with the most toxic animal. Can anyone pull that one?
Yeah, so I actually wrote this article you can see up there for the week Junior Science and Nature. And it really depends who's eating it. I think the answer always depends who's eating it, because there are some incredibly toxic animals. But probably the crown for the most toxic goes to animals like this beautiful dart frog up there. And all its skin is toxic. It kind of oozes toxins as a protection. So just one lick, even just picking it up, can give a dose of poison enough to kill. So I think that's probably the most toxic.
Yeah.
I've got an interesting story about this. So I was reading about this. So a Victorian scientist, so 200 years ago, his idea was that colourful birds aren't poisonous because the colours scare away their predators, whereas like brown-coloured birds, they are the poisonous ones. So to answer this question, he ate every single bird he could find. He ate like 300 different birds. Then he also fed them all to his cat as well. And there's a research paper you can find, and it's basically, this is like 100 pages long, because it's like the common grouse. I could eat it, my cat could eat it. This pigeon, I could eat it, my cat could eat it. And he was wrong.
He must have found out the hard way. My cat can't eat it, I can't eat it.
He would feed it to the cat. He fed it to his cat first, and if his cat looked a little bit ill, he was like, well, maybe I'll skip that one. But there we go. That's what scientists do. We answer questions.
But we don't always kill cats.
I think that's a really good... That's a really
Well, cats have had a bad day.
Yeah, they do.
Everyone who ate one of the insects later on, you four can tell us which is the least toxic.
There we go. Insects are the least toxic thing because they're perfectly safe
They're
to
very
eat.
widely eaten, aren't
Yes.
they?
Wow, fantastic. We've had an exploration of the outer galaxy, the strange world of science and scientists and the curious and strange things they get up to, and also, the impossible questions. So thank you very much. I've got 2 questions for you before you go away. First of all, did you enjoy yourselves? Let's give them all a big, big clap then. Thank you very much.
Thanks for your questions.
And second of all, who here reads the Week Junior Science and Nature? Let's have a quick show of hands. Fantastic. Well, those that don't, you're in for a treat, because we've got copies for you on the way out. Hey. And Isabel and Pete and Maggie will be signing books at the festival bookshop after this, directly after this, so you can go see them, have a chat to them. Thank you very much.
That was How, What, Why, expert answers to crazy questions at Cheltenham Literature Festival 2022. And remember, we're back in a few weeks with a brand new series of Mysteries of Science. Stay curious.
Thanks for listening to this podcast, which is made by the same people that make the Week Junior magazine. You can get 6 free issues of the Week Junior or 3 issues of the Week Junior Science and Nature for £5 by heading to theweekjunior.co.uk/podcast offer.